Hi students, this is Alex here. In this video, we are going to find the Fourier series of periodicity 2 pi for the given function f of x. We have a function from minus pi to 0 as minus pi and from 0 to pi as x. So we are going to find whether it is even or not. So the first part of the function I'm going to take it as g1 of x, which is minus pi, and second part of the function I'm going to take it as g2 of x, which is x. When I change g1 of x as g1 of minus x, it means every x has to be changed as a minus x, but here there is no x, so this will come as it is. But anyway, this is not equal to g2 of x. Whether it has to come same as g2 or negative times g2, so to conclude it is even or odd, but the function is totally different. Therefore, it is neither even nor odd function. So it is neither even nor odd function. Now we are going to find a naught, which is 1 by pi integral minus pi to pi f of x dx. But our function is made up of two parts. So first is minus pi to 0. That time f of x is minus pi dx. And again we take that 1 by pi common, or we take it for the second term also. Now 0 to pi is our second interval and the function is x. Now we are going to integrate this and apply the limit. The first one is minus pi. Its integration is minus pi into x. And outside we have 1 by pi and we have to apply the limit minus pi to 0. Then here it is 1 by pi. X integration is x square by 2. Limit is from 0 to pi. When I cancel this, we left with minus x. Applying the upper limit, we get minus 0. Then minus of, we have to apply the lower limit. So minus pi. But already there is a minus sign. So minus or minus it becomes plus. Then for x it is minus pi. Then coming to this 1 by pi into pi square by 2. So we can cancel this. Now we have minus pi plus square by 2. Sorry, pi by 2 because we cancelled the pi. Now by taking LCM, this becomes LCM is 2. So minus 2 pi plus pi, which is minus pi by 2. So a naught equal to minus pi by 2. So we got a naught. Next we are going to find a naught, and a naught formula is 1 by pi integral 0 to minus pi to pi f of x into cos nx dx. But this function is made up of two parts. So we are going to split this into two integration. One is 1 by pi integral minus pi to 0. When it is from minus pi to 0, our function is minus pi. So in place of f of x, we have to put minus pi cos nx dx. Again plus 1 by pi integral 0 to pi. So when the limit is 0 to pi, our function is x. So we take x into cos nx dx. Now the first part we can integrate as usual, that is 1 by pi, and minus pi can be taken outside, so minus pi can be taken out. Integration of cos nx is sin nx by n. And when I apply the limit, both the limit, minus pi if I take for sin it is 0, when I take 0 it is also 0. So the first term is totally 0. But here we have to apply Bernoulli's formula. This is u and this is v. Formula is u v1 minus u dash v2 plus u double dash v3 minus u triple dash, like that it keeps going. So now it is 1 by pi bracket open u, which is x. v1 is from v, if I integrate I get sin nx by n minus u dash, x differentiation is 1, Then sin nx by n integration is minus cos nx by n square. And u double dash will become 0. So we stop here and we put 0 to pi. I write this separately. What is u, v, u dash, v1, everything here for better understanding. So u is x and v is cos nx. So u dash is 1, u double dash is 0. Here v1 is sin nx by n and v2 is minus cos nx by n square. So I substituted here. Then when I apply the limit for the first term, upper limit is also 0, lower limit is also 0, so totally it is 0. Now this is 1 by pi. When I apply upper limit, sin n pi is 0 and this I can make it as plus, and cos n pi is minus 1 whole power n by n square. When I apply lower limit, first part is anyway 0, second part is 1 by n square. So totally the term what we have is 1 by n square, bracket open, actually pi n square I have taken common. So here it is minus 1 whole power n and minus 1. And whenever n is 1, 3, 5 like this becomes minus. So we are going to get, we'll write it here itself. If n equal to 1, 3, 5, that is odd number, then the value of an is 1 by pi n square. This becomes minus 1 and already there is another minus 1. So totally it is minus 2. So we get minus 2 by pi n square. Suppose if n is 2, 4, 6, 8 like this even, then minus 1 whole power even number is 1. 1 minus 1 is 0. So we get an equal to 0. It means this an is having two parts. One is for odd and another is for even. So we can clearly state it here. For n is odd here and here n is even. So we keep this as it is. Now coming to bn, the formula is 1 by pi integral minus pi to pi f of x into sin nx dx. So this is 1 by pi integral minus pi to 0 I have to take because the first part of the function is minus pi into sin nx dx, and 1 by pi integral 0 to pi, second part of the function is x sin nx dx. Now we are going to integrate the first part. We can cancel this. So minus sin nx integration is cos nx by n, and we are going to apply the limit from minus pi to 0. And here we have to take u equal to x, p equal to sin nx. We are going to use Bernoulli's formula. U dash is 1, u double dash is 0. Its integration is minus cos nx by n. Again v2 is minus sin nx by n square. Now applying the formula here, this is 1 by pi. Bernoulli's formula is u v1 minus u dash v2 plus u double dash v3, like this, dot dot dot, keep going. Now when I put limit here, this is 1 by n minus cos n pi is minus 1 whole power n by n. Cos minus n pi is also minus 1 whole power n. And here it is 1 by pi. Let's put all the terms. This is x. v1 is minus cos nx by n minus u dash is 1. v2 is minus sin nx by n square. And our limit is from 0 to pi. Now first term, this is 1 minus of minus 1 whole power n by n. And here 1 by pi, when I apply upper limit, this is pi into, this is minus 1 separate, and minus 1 whole power n by n, because cos n pi is minus 1 whole power n and already there is a minus sign, and sin n pi is 0. And when I put lower limit, everything is 0 because there is a x here and this is a sine term. So both are 0. So now we left with 1 minus minus 1 whole power n by n. And here it is 1 by pi into pi minus 1 whole power n. We can cancel these two. And there is also n. So we can make a common denominator whole divided by n. So this is 1, and these terms are similar, that is minus of minus 1 whole power n, here minus of minus 1 whole power n. So I can make it as minus 2 into minus 1 whole power n. So finally we got Bn. Bn is 1 minus 2 into minus 1 whole power n by n. Now we are going to substitute this in the Fourier series expansion formula, that is f of x equal to a naught by 2 plus summation n is equal to 1 to infinity an cos nx plus summation n is equal to 1 to infinity bn sin nx. So f of x will become a naught by 2. Already a naught is minus pi by 2. So when I divide by 2, we get minus pi by 4 plus summation n is equal to 1 to infinity, but this exists only for odd. So n is odd to infinity because for even it is 0. Minus 2 by pi n square. So minus 2 by pi n square into cos nx. Then plus summation n is equal to 1 to infinity. Bn is 1 minus 2 into minus 1 whole power n by n into sin nx. Now f of x equal to, just a small rearrangement, minus pi by 4 and minus 2 by pi can be taken outside. We have summation n is equal to odd till infinity cos nx by n square, and here we can write as it is, summation n is equal to 1 to infinity 1 minus 2 into minus 1 whole power n by n into sin nx. So we got the Fourier series expansion formula. Now as a second part of the question, we have to deduce 1 by 1 square plus 1 by 3 square plus 1 by 5 square equal to pi square by 8. So for that I have to take the value of x as 0. So this becomes f of 0 equal to minus pi by 4 minus 2 by pi summation n is equal to odd till infinity, and cos 0 is 1, so 1 by n square, and here sin 0 becomes 0, so totally the last term is 0. And f of 0 we have to find. F of 0 is actually, by convention, we take usually x greater than or equal to 0 here. So f of x value is x now at 0. So if I take f of x as x, and when I find f of 0, it is actually 0. So 0 equal to minus pi by 4 minus 2 by pi, and this I am going to expand. I am going to put odd numbers. So 1 square, the next odd number is 3 square, the next odd number is 5 square, plus dot dot dot. It is keep going like this. So this can be taken to the other side as pi by 4 equal to 2 by pi and 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus dot dot dot, keep going, and this pi will be multiplied to the numerator, so pi into pi is pi square. This 2 will be multiplied to the denominator here, so pi square by 8, which is 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus dot dot dot. So finally we got 1 by 1 square plus 1 by 3 square plus 1 by 5 square is equal to pi square by 8. So let's rewrite this. Therefore, we got this proof 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus dot dot dot, which is pi square by 8.